Welcome. In this video, I'm going to go over solutions to the problem set from 4.4 and 4.5. Number 27 gives you 5 unknown substances and some descriptions, and it tells you your choices for each. So as I look at these, the nonpolar molecule should be the easiest one to identify because it's going to be insoluble in water, and it should have the lowest melting point. So I can fairly quickly figure out that D is going to be my nonpolar molecule. So I'm going to go ahead and label this here. Just put a little NP here. So that one's off the board. My ionic is going to be soluble in water, and it's going to make it conductive in water, but it's not going to be conductive in solid. So E, I'm going to come up with as being my ionic compound. And then when I look at what's left, my giant covalent, my metal, and my polar, I know the polar one is the one that's going to be soluble in water, okay, but it's not going to be conductive because polar substances don't have the ions being released in there. So this is going to be, my C, I believe, is going to be my polar molecule. And then I'm left with my giant covalent and my metallic. And they're both going to have relatively high melting points, but the difference is the metal is going to be able to conduct as a solid, whereas the giant covalent will not be able to. So that's the order I would come up with on 27. 28, which substance is the most soluble in water? Well, for sure the OHs are going to be more soluble than the hydrocarbons because those are going to be considered nonpolar. So what you're supposed to pick up on is the OHs are going to make it more soluble. And then the question is it better to be just a CH3 with the OH or to have 2 carbons with the OH? Well, this has more nonpolar to dissolve with it, making this the more soluble. So 28A would be your most soluble. Number 29, state the intermolecular forces that exist between molecules of each of the following. Dry ice or CO2, so you really have to know what the structure looks like. So dry ice is linear, so it's nonpolar. So this just has dispersion forces between it, or London forces. NH3, on the other hand, has got a trigonal pyramidal shape, and it's got hydrogen bonds. So what IB wants you to realize is it has hydrogen bonds, but then it also has dipole, and London forces, so it has all the weaker ones as well. As you develop each of these higher ones, the lower ones still are there. N2 is also going to be a nonpolar molecule, so that's going to be just London forces, London dispersion forces, or your book likes to abbreviate it LDF. And then CH3OCH3, this looks like it might have hydrogen bonds, but its structure is going to look like this. So it just has dipole, which means it also has London dispersion forces. So just LDF, this one has hydrogen bonds, and then you have to mention that it has dipole, and the London dispersion forces. The N2, which I didn't draw, is just LDF because it's nonpolar. And then this one has dipole, as well as London dispersion forces. 30, which of each pair has the lower boiling point? So the lower boiling point is going to be the less polar one in each case. Or if they're both nonpolar, it's going to be the heavier of the two. So when I look at number 30A, those are both polar molecules. They're going to be fairly linear. C2H6 and C3H8. C3H8 should be, I'm sorry, I'm looking for the lower boiling point. So C2H6 will boil easier because it's a little lighter, even though they're both nonpolar. H2O and H2S. Here it's the hydrogen bond's going to drive water's boiling point way up, so H2S should have the lower boiling point. Cl2 and Br2 are both going to be polar, but again, the lighter Cl2 will boil easier. HF and HCl. Here, these are both crazy polar, so even though HF is lighter weight, HCl is going to be less polar and have the higher boiling, or have the lower boiling point. So those would be my choices for each pair. Okay, and then I'm going to finish off the practice questions by squeezing 31, 32, and 33 in here, because I realized I forgot to cut those questions out and make a slide for them, but I think I can squeeze them in here. So if I slide this up a little bit. 31 simply asked, which is the best definition of metallic bonding? And if you don't have your book close by, your choices were A, attraction between cations and anions. It's not a bad definition, although they're not true cations and anions. B, the attraction between cations and delocalized electrons. That sounds better because the anions are actually just the delocalized electrons. C, attraction between nuclei and electron pairs. Nope, they're not paired up. Or D, the attraction between nuclei and anions. So B is the best choice. We describe the nuclei as cations, or the positive nuclei from each metal, and they are then attracted to the delocalized or freewheeling electrons. And that's why they have so much in common with ionic bonds. Number 32, aluminum is a widely used metal. What properties make it suitable for the following applications? So A, they want to know, why can you use it as baking foil, or what we commonly call tin foil? Well, a couple reasons. It's flexible. It has a high melting point, so it's not going to melt into your food. It's a good conductor, specifically a thermal conductor, so it conducts the heat well. So that all makes it a good baking foil. B wants to know, what properties make it good for aircraft body work? Well, again, it's lightweight. That's definitely a bonus with aircraft. It's durable. Doesn't wear off easily. And it's non-corrosive. Aluminum is not quick to react with things in the environment typically. C wants to know about cooking pans. Again, lightweight, durable, non-corrosive. Those are all good things for cooking pans. Also being a good conductor is a bonus. High melting point is a bonus. The big knock on aluminum now is that it's been linked with Alzheimer's, and I don't know if that's been proven definitively that there is a link or isn't a link, but they certainly see a correlation that high levels of aluminum have been found in brains of Alzheimer's patients. And then D, tent frames. Lightweight is good. Flexible is good. Durable is good. And non-corrosive would be the really desirable characteristics in a tent frame. And then 33 says, suggest two ways in which some of the properties of aluminum can be enhanced. So you could form an alloy is what they're getting at. It would be one way. Let me see if I can scroll this up a little further. I can squeeze in again. So two ways you could enhance it is to make an alloy, perhaps to increase strength, or to enhance some other characteristic. But an alloy is when you mix it with another metal. And B, the other one would be what we call is anodize it. And what that means is that you oxidize the surface to protect it. And that means you go ahead and let the surface react It's sort of like with copper when it gets that green patina, it's a protective surface. So you oxidize the surface to protect layers below. And those are the problem set questions, the exercises from problem set 4.4 and 4.5.